This video demonstrates how Dynomotion's KFLOP Motion Controller can be interfaced to National Instruments LabView graphical programming environment. If you go to the National Instruments website, there should be a page where you can download a trial evaluation for up to 45 days. After the big download, LabView can be installed and then launched, and we can create a first project. Here we select Create Project, and we select a blank BI template. The first step is to add a .NET constructor. To do that, we open the function palette, go under Connectivity, .NET, and select a constructor. We then browse to our .NET assembly. That would be in the installed KMotion directory under KMotion release, and it's the KMotion.NET DLL. It shows all the objects that are available. We'll select the KMotion controller object, and there's two constructors for that object. We'll pick the one with no parameters to make it simple, and there we have it added to the diagram. The next step is to add an Invoke Node, so we can invoke a member function. Notice this is a generic .NET object until we wire a KMotion controller node reference to it, and the error out. And now this has became a KMotion controller invoked, and it is now populated with all the methods that are available. And we will select a write line member function to be able to send a script command to KFLOP. The write line command requires a string input for what script command to send. LabView allows you to quickly create a constant as an input parameter, and we'll add in a string that says move relative axis 0 100,000 counts. Notice the run button is now highlighted because we have a complete program, and we're now able to issue our first command to KFLOP through LabView. Very simple. Shown here is a virtual instrument LabView example included in the KMotion download. It's called KMotion.NET DLL sample, and it's located in the PC LabView examples directory. There is an additional sub-virtual instrument file called console.vi used to handle console message events from KFLOP. Also an example KFLOP C program to initialize some motor axes and send a console message. This is the C program that will be invoked by the sample. The example will display the board type, compile and execute a C program to KFLOP, then loop providing a motor jog capability and a DRO position readout. Here's the front panel GUI. It has a board type display, DRO for the axis 0 position, and a jog slider to control axis 0 jog speed. Switching to the block diagram, we can see it starts off with the KMotion controller constructor. There's a property node which requests the board type property and displays it on the screen as a board type. It then uses an Invoke Node to compile and load a KFLOP file into thread number 1 using this string as the program name. If the output is successful, it enters this conditional to execute the C program. Any compile errors will also be shown on the display. In order to receive the asynchronous, unsolicited callback console messages, a registry event callback is executed. You can add this from the .NET palette. Select which event you would like to register here. We've selected the message received. Then right-click on the VI ref and allow LabView to automatically create a callback VI for you. The VI callback is a separate component, and it includes automatically all these components that are part of the callback. We look at the block diagram. These components were all added automatically because they're defined as part of the object. And we have added these controls in order to take the event data from the callback, unbundle it, send it to a one-button dialog with an OK button for the user to acknowledge. If we close these and go back to the main diagram, after the callback is registered, we go into a while loop that loops forever until the stop button is pushed. And this requests a destination of axis 0 by sending a write line read line, and it takes the result of that coming back to LabView and processes that into a number and puts it into the position DRO on the main screen. And also, each time through the loop, we are reading the jog slider, converting it into a jog command for KFLOP, and sending it to KFLOP. We can now switch to the front panel and run the demo. Here we'll push run. Notice the console message comes back and is displayed in the message box. There was no compile errors. And we can jog the motor. And we can stop the program. That's it.